Okay guys, so let's start. So it's all about again STP. So yesterday we have discussed about the basics of STP, okay, and basic process also we have discussed yesterday, okay. So if I'm talking about, let's just go with the quick revision, okay. What is the first step here? What is the first step?
First step.
First step. Why do we need
Okay.
Why do we need STP?
Just not to be in the loop.
To
Not to be in the loop.
to prevent the
Not one.
loop. Okay. In STP, what is the switch priority? Switch priority by default.
By these three, you are asking the value.
Yeah, value I'm asking.
I don't remember exactly.
Why? 3, 2, 7, 6, 8 there. What is the first step? Next, Rakesh.
Find out the road path.
Root path. Okay, very good. Next, what is the first step in that STP process? To find out root bridge. What is the second? No, I asked you first path.
Okay.
First one.
Find the best path.
Find the best path. Okay. So now let's consider, guys. Yesterday we have discussed about the 3 switches. Just consider today it's all about 2 switches. Different topic. How many switches do we have? 2 switches. Both the switches are connected like this way. Okay. So this is switch 1 and with MAC address A. This is switch 2 with MAC address B here. This is first interface. It's all about F00. This is again same F00 here. This is all about F0/1 and this is all about F0/1. Okay. By default priority is 32768 and by default priority here 32768 here. Okay. Now, which VLAN do we have by default? VLAN 1. Now, so we have switches. Okay, let's consider. Here we have one end device which is connected with this particular PC here. Oh, sorry, with this switch, and we have another device which is on this side here. Okay, and connected with this one. Okay, 2 devices. Now, we have to transfer the data from where to where. I have to share the data from the PC A to PC B. First of all, if I'll share the data from here, okay, this is a switch, single broadcast domain will be there, from there, loop will be there. So we have to avoid the loop. So for that thing, what are the concept we are using? We are using STP here, spanning tree protocol. So in the spanning tree protocol, there is mainly 2 steps. The first step is find out root bridge, and second is find out best path here. Find out the best path there. In the best path, then we have the different options there. First, find out root port, then find out designated port, and then find out alternate port here. Okay, alternate port. What is the state? That is block state here. So in this one now, how many options do we have? 2 switches we have, and we have to find out best path here. Okay. In this scenario, A means it's all about 10 and B means it's all about 11. Okay, so let's start it. So first of all, both the switches, they will exchange what? They will exchange the BPDUs to each other. Bridge protocol data unit here. What is the MAC address for the BPDU? So 0180 C2
colon following between columns 00004.
0, 0. Okay. So this is all about MAC addresses, Bpdu MAC addresses. So now we are using two switches here. So they will exchange the Bpdu, and first of all they will find out which is your root bridge. Okay. So for the root bridge, which parameter we are going to be used here? Yes, you. What is the parameter? For I have two switches and we have to select root bridge. So what is the parameter they are going to be used? Because now election process will be there. So what is that parameter? What they are going to be used? Lowest path cost or what?
Lowest path.
Lowest? Root port. What is the parameter here?
Priority,
That is all about
bridge ID.
bridge ID. Bridge ID is a combination of priority plus switch MAC address. Okay. So now on the both the switches 32768, 32768, that is same. It's tie. We need a tiebreaker. What is the tiebreaker? MAC address. So this is A. This is what? B here. So who's the winner? A is the winner, because always lowest will be the winner there. So now who's the root bridge? Root bridge. Clear? And this is what? It's all about non-root bridge. Okay. This is root bridge. So can I mention here if this is my root bridge? So yesterday we had discussed this thing. Can I mention here DP and as a DP port here? Clear? Okay. Just randomly mention it. Okay. And if you don't want, no problem. Okay, we will find out. So step number 1 is done. What is that? Just find out root bridge here. What is the second? Find out best path here. In the best path, what is the first step now? First path is lowest cost. What is the first step now? First find out root port. In the root port, now what is the first step here?
Lowest path.
Lowest path cost here. Lowest path cost here. Okay. Now, so I have to find out what? I have to find out root port, right? Root port is always possible on the non-root bridge switch. This is always where? On the NRB. Okay. 1 NRB means equals to 1 RP here. Okay. Now, how many interfaces do we have? 2. This interface saying, claiming I'm the root port, and this saying no, I'm the root port. Then we will use what? Parameters. We have first parameter. What is that? Lowest path cost here. So in the lowest path cost, I'm using this as my 100 Mbps network. What is the network here? 100 Mbps. So now, what is the cost here? 19. What is the cost here? 19. Right now, I'm where? I'm on NRB. So what is my destination? RB. From non-root bridge, where do I have to go? I have to go to root bridge there. So how many exit interfaces? 2. If I'm using this one, what is the cost? 19. If I'm using this one, what is the cost? 19. It's tie or not? Now we need one tie breaker here. Okay. What is the second tie breaker? Check it. Sender bridge ID. What is that? Sender bridge ID. Sender. Who is the sender here? A is the sender. What A is sending? A is sending now Bpdus. A is sending what? Bpdus here. Actually, who can exchange the Bpdu? Only root bridge can exchange the Bpdus there. In the starting, first time, everyone they were exchanging what? Root bridge, because on that time everyone were claiming I'm the root bridge. But now they decided, and who's the root bridge? This is the root bridge. So it means who can send the root bridge? This guy can send the root bridge. So on NRB, on this interface, we are receiving the BPDUs here, and we are receiving the BPDUs on this interface. BPDU is coming here, BPDU is coming here. Now this switch will check it. Who is sending the BPDUs there right now? Who is sending the BPDU? A is sending the BPDU. Then they will compare the bridge ID. They will compare bridge ID of the sender. If I am receiving the BPDU here, who is sender for me? This switch. What is bridge ID? 32768 and A. On this interface also I am receiving what? BPDUs from the same bridge here. So what is the priority? 32768 plus B here. Oh sorry, A only. Let me compare. It's same. Again it's what? Tie. So we need what? We need what? Tie breaker. Clear? Now, this is clear or not? So this is bridge ID. So next concept is sender port priority. This is not switch 1. 32768 what? That is switch priority. Now it's all about interface priority here. Okay. What is the interface priority? 1 second. So this time interface, not the switch. 100 is there. What is the switch priority? Oh, sorry, interface priority. That is all about 100. Coming back here. What is that? 100 here. What is the priority over here? 100. Now, we are receiving who's the sender for this one? This is the sender. What is the priority? 100. For this one, what is the priority again? 100. Again tag. Now we need port ID. What we need? Port ID. What is the port ID here? F01. I'm receiving now. I'm F01. Okay. It could be F02 also. Doesn't matter. So now when we are receiving the BPDUs, we are receiving the BPDU from where? F00. This guy is receiving the BPDU from F01 because here F00 is not possible again. Because on maybe what are the possibility? F00 is there, F1/0 could be there. This is one more possibilities. Okay, but different NIC card. On a same switch, on the two interfaces, same ID is not possible. Clear? So this is what? F00 and this is what? F01. I am receiving FTD here from where? F00 and this is what? F01. If we will compare these two things, which is the lowest one? F00. So it means this is what? This is my this is what? This is the root port. Go with segmentation. And this segmentation, one root port is already there. What is the second option? And this is the root bridge. Obviously mentioned here. Sorry, as a DP port here. And this is also again what? DP port. And this is the DP on this switch. That is now RP is not possible again because one and RP, one RP. So what is the second option? It's all about alternate port here. What are the states? These are the port roles. What are the states here? Forwarding, forwarding, forwarding. It's all about block. That is that. Clear? Note it down, please.
So what's 19?
19 is path cost. Path cost. Fixed path cost.
For like 400
Mbps.
100.
400 Mbps is 19. I told you yesterday, if your speed will increase, cost will decrease, inversely proportional to each other.
About BPDU. Let's say a root bridge is sending a BPDU to switch B, and will switch B broadcast or not send it to anybody?
No, it will send to the from the like now. Let's consider further if you have more one more switch here. So from RP port always receive the BPDUs. It can't send it. So after that, we have maybe I have one more DP port here, one more DP port here. So from remaining DP ports, it will forward that BPDU to the next switches. Okay, that topology will be there. Next is that one. RP port just can receive the BPDU, can't transmit it. What about your terminal server task? That is completed? Terminal server.
There's no connector.
Hmm?
Connector is not there.
Connector is not there. Okay. What about MAC address header? Who will explain? MAC address header. You remember? During OSI classes, one task was there for MAC header, Ethernet MAC header. Yeah, Ethernet MAC header, same thing. That's good. And in group only 7 to 8 student has shared their this one task. What about other guys?
BTP.
Yes.
I'm done.
Have you shared? Why?
I did day first.
7 to 8 only.
I'll share it today.
Why today? No, I don't want today. Don't share now. If you will share, I'll remove you from the group immediately. Because I'm not gonna ask you again and again. This is by default. Whatever practical I'm doing in the class, same thing you have to perform on GNS first, or maybe packet tracer, whatever you are using, and you have to share the snapshots in the group. That's it. That is by default. Don't wait. First I'll ask you and then you will share. That is by default. Okay, it's done. This one. This case done, everyone. Okay, let's go with the next topology here. So this time now switch 1 now switch 2 3 4 2 3 4 5 6 7. Okay, now we are connected with this one. Okay. Now, all about A, all about B, C, D, E, F, G. Clear? Now, so 32768, that is common. Okay. What is the priority? That is all about 32768. Any doubt? Anyone? What is the first step? First, find out root bridge here. They will exchange what? They will exchange BPDUs. Okay. Just compare all the links for first switch priority. What is that? 32768. That is what? Tie. Behalf of the MAC address. Who's the root bridge? A is the root bridge. Who's this one? Who's the root bridge? This is the root bridge now. Now, if this is the root bridge, obviously this is DP and this is what? DP here. Any problem? Any doubt? Now, find out root. Now, first step is done. What was that? That is all about root bridge. The second is about find out best path here. In the best path, what is the first step? That is all about root port. Then second is all about DP port, and third is all about your alternate, that is also known as NRB. Okay, non and DP, non designated port. Okay, so first step number 1, root bridge is done. So remaining is what? That is all about NRB here. That's all about NRB. NRB, and it's all about NRB. Clear here? Any doubt? Now, next is what? We have to find out root port here. Root port is also always possible where? On the NRBs. How many NRBs do we have? 6. So let's go with that. So first of all, if I'm coming with this one, on this one we have to find out what? Root port. How many options do we have? 1, 2, 3, 4 options there. Let's find out. 100 Mbps network I'm using here. So what is the cost?
19.
It's all about 19, 19, 19, 19, 19. Let's consider from first this interface. What are the cost? 19. What are the cost from here? 19 plus 19, 38. First one 19. Second is what? 38. From here 19, then 19, and then 19. It's all about 54. Then from here 19, and from here again I have 3 different paths. 1, 2, 3, 4. If I'm going from here 19 plus 19, and then again 19, then from here 19 plus 19 plus 19. Okay, means that is minimum is all about 54 here. So which is the best one? 19 here. So it means this is what? This is all about root port. All about root port. Same here, it will be what? Root port. Any problem? Okay, just now come with this one here. How many NRBs do we have? See here. On this NRB, how many interfaces? 1, 2, 3, 4, 5 interfaces. Cost is what? 19 plus 19, 38. 19 plus 19, 38. 19 plus 19 plus 19, 54. 19 plus 19 plus 19 plus 19, 73. 19 plus 19 plus 19 plus 19 plus 19, almost 195 to 95, near about that. Okay, which is best one? 38 and 38. In 38, how many? It's again tie. So means there is a tie between the how many interfaces? These, this path, and this path. Tie. I need tiebreaker. What is the second option? Second option is bridge ID here. This guy is sending. This is the root bridge. This guy is sending what? Bpdu to this one, and now this NRB sending the Bpdu from where to this one. This interface, on this interface we are getting the Bpdu from where? B, and here we are getting from where? C. Which is the lowest one? B. So this is what? It will be root part. Clear? Come back here on this interface, on this one. 19 plus 19, 38. 19 plus 19, 38. 19, okay, sorry, this one. 19 plus 19 plus 19, 54. 19 plus 19 plus 19 plus 19, 73. 19 plus 19 plus 19 plus 19 plus 19, almost 95 here. Again, there is a tie between this one and this one. We are getting here from C, we are getting from here where? B. So obviously this is what? This is root part. Go with the next one. How many interfaces? 3. 19 plus 19 plus 19, 54. 54, 57. 57. 19 plus 19 plus 19. Again, 57. 19 plus 19 plus 19 plus 19. Near about 73. There is a tie between these two ones. I am getting the Bpdus from where? D. I am getting from where? E here. D is the lower. So this is what? Root part. Same here. 19 plus 19 plus 19, 57. 19 plus 19 plus 19, 57. 19 plus 19 plus 19 plus 19, 73. There is a tie between these two ones. This is the E, this is D. We are always getting from where? D is lower. So this is what? It will be your. Clear? Go with now. Here go with segment concept. It's all about two possibilities are there. One is DP plus RP and second is DP plus alternate. Clear? So if I'm talking about this segment, this is already done. This is RP. RP is there. What is the second one? It's obviously this is all about DP here. This is RP. This is what? DP here. This is RP. This is what? DP here. This is RP. This is again what? DP here. Any problem? No? All RP is done. Okay. Almost DP is also done. Now which combination is pending there? Now DP plus alternate. In this segment, is there anything? We haven't decided anything. There's nothing is there. Let's first, if I'll go with the DP, another port will be what? Alternate. Compare their bridge ID. B and C, which is the lowest one? B. So this is what? All about DP, and this is what? This is all about alternate port. This is what? It's all about here alternate port. All about alternate. Okay. Now in this segment, okay, this is also done. In this segment now, I'm talking about this segment. B or C? C is the one, lower one. So this is what? It will be DP, and this will be alter. Okay. Between D and E, D is the lowest one. Okay. So this is what? DP, and this is all about what? Alter. Okay. Then between this one, E or G, this is all about DP, and this is all about what? Alter. Okay. In between this one and RB or this one, F or G, this is all about DP here, and this is all about what? About alter.
Same for FE also.
Yeah, same for FE also. This is all about F or E. This is all about alter here, and this is all about what? DP port. Designated. where? Okay.
Yes, yes.
DNC, this is all about DP, and it's all about alternate. All the alternate ports always in which state? That is always in the block state here. So this interface is what? Block here. This is what? Block here. This is again what? Block here. This is all about block here. All about block. All about block. Clear? Let's consider we have a device here, or we have device here and one device here. I have to exchange some data from A to B here. So how the data will travel? First of all, it will come to the NRB. What is the root port? Best exit interface. It will go from here only. Now where I'm on this NRB, what is the root port? This one. I'll go via this one here. This is what is the root port? This one here, and now finally I'll be here. Same in case if there is a one device here, and from here if you are generating any traffic, it will be here. What is the best exit interface? Root port. It's all about from here. This NRB, what is the root port? This one. It will be this one, then finally it will be here. If you have any device here, it will be here now. What is the root port? This is the root port. Exit interface from where it will be. So first thing, it will avoid the loop, and second thing, it will find out best path over there. On the switches, we have a protocol that is all about STP. Okay, and which you can say STP on the switches. If I'm talking about, we use STP protocol to find out the best path, and on the routers we have routing protocols which we use to find out the best path. Okay, so this is all about. Note down this one, and otherwise use the MAC addresses and try to solve this thing yourself. Do it fast. 2 minutes. What is your task in the same scenario here? You have to use MAC address A here on this switch. Okay. After that, any MAC address you can use anywhere. Means this switch you have to use as a root bridge, and then you have to find out the remaining port. This is your task from the home. Okay. Don't use this switch as a root bridge. This one you have to use. Okay. Not now. This is task, okay, from home, which you have to finish it. You guys done?
I have one doubt.
Hmm.
Now this the switch A is there, no?
Hmm?
From there switch A.
Hmm.
From there, how to communicate to the switch E?
Switch.
Switch E.
Switch
What will
E
be the route for
from DP. It can become from here also. Okay. From here now. After that, it will be from DP because now reply is coming back. It's not about root port. It will come back from the DP over there. It will use the same path from where your request is going out.
if the packet is generating from the switch A?
If it's generating from switch A, it will be how many options do we have? DP2, it can become from here, it can become from here again. After that, it's all about which interface, or which switch you are talking about? E,
Yeah, anything.
anything. So after that, it's from the this proportion as well and from the this one as well here. Okay, because spanning tree is all about from NRB to the RB, not from RB to the NRB there. If you are sending any request, reply will be from the same path. Otherwise, if you're talking about keep data will become from where? It's from here. So now let's consider you have one device is connected. The first thing, directly on your root bridges, we can't add any devices. On the root bridge, we can't like connect any devices over there. There, let's consider the switches possibilities. Means if you have to connect any device, that is always on NRPs, not on RPs. In corporate, this is the practice. On root bridge, you can't add any end device. Okay, so it's always on NRPs. That was just an example. I was just telling you about what is the best path, because the best path is means you have to go to your root bridge here. That is the thing.
Initially, there's a network which is connected to a number of devices. Then only we are finding the root bridge, right?
Sorry.
Initially, there's a network which is connected to a number of devices. Then only we are finding the root bridge, right?
No, you were absent yesterday, I think.
I saw the video.
So see, anytime when you are connected switches, okay, let's consider now this is connected, STP will be there.
By default, it will be there.
By default,
30 seconds.
By default, it will be there. There's a nothing. Your devices are after the first we have to connect the switches. After that, you will connect the and devices on that time. So that doesn't matter for us. So first, once you will connect the switches, immediately STP will be there by default. Okay, that doesn't depends on your n number of depends on number of and devices. And number of devices, 2 devices, 5 devices, doesn't matter.
So in a single link STP is possible?
Yes, that is also there. Let's consider if you have 2 switches. Okay, we are connected with this one, and this is your root bridge, and this is what? NRB. We had decided. Okay, this is what? DP port. Here I need what? RP port. Done. That's it. If you have another one more link,
DP and outlet.
this is about what? Now loop is there, it will be DP, and this is what? All about alternate port. If you have one more interface, this is again what? DP, and this is what again? Alternate port here.
In a single loop
No, how loop is
So
there?
how there will be STP there?
But STP is by default enabled. You can't remove STP. It's by default behavior of the switch is by default property STP is there. Maybe loop is there or not, that doesn't matter. Okay, because your switch won't wait if once two connection will be there then STP will be enabled. No, once you will connect immediately STP will be there. Okay. Now connect here 1000 of devices, 1000 of cables there. All the cables will be in the which port? It's about block. Out of 1000, one cable will be as a RP and DP because on NRB only one RP is possible. So out of 1000 devices, let's consider I'm using here 10 cables. Out of 10 cables, how many cables I'm able to use? One. Is that advantage or disadvantage? Disadvantage. Then one more concept will be there. Ether channel. Because we have advantage of that, that's okay, but we have disadvantage also. Then one more concept there, Ether channel. And luckily it's not the part of your syllabus. Okay, that you will learn in the CCNP. It means physically 10 cables are there. Virtually it will merge all the cables. Physically this is concept there, but virtually that will be act as in a single cable. And on the single cable again, now STP will be on your this link, not on the physical cable. So this is it will become what? DP, it will become RP. Okay, so that is all about Ether channel concepts there.
I have another doubt. So,
Yeah.
no, not the STP. So let's say I'm connecting a device to B.
Connecting a device with
B.
B here.
And I'm connecting a device with G. GG. Okay. Yeah. So from device G, I mean the computer connected to G, I'm trying to ping the let's call this device computer B.
Computer
Yeah, this
B.
computer. Okay.
Yeah.
I'm trying to ping 192 whatever. I'm giving this IP address. Now how will the ARP resolution and all of that happen like?
See, now once you will done here, ARP will be about what? ARP is always again broadcaster. From here I can't send anything. One option is there. From here it will be here now. Okay. Now again alternate port we can't send anything. It will be from here. It will be here. It will be here now. Okay. After that again because I'm doing broadcasting. This is not unicasting. Unicast will be directly from the RP and it will be out here. It will be there now. It will be to this one. It will be to this one there.
Oh, and then we'll trace back.
Exactly. That's it. Because on alter from block port, okay, we can't send or we can't receive anything. That's it. Okay, but BPDUs we can exchange on alternate port. Yesterday I told you we can't receive or we can't send anything, and what is all that is all about? Data. But on alternate port we can receive or we can transmit BPDUs. Okay. First of all, first time when we will exchange the BPDU, that is all about for the selection process of STP. Once your now my STP is done, after that again they will exchange the BPDU, but this time they will exchange the BPDU as a keep alive, like summary advertisement. Okay, so again BPDUs will be there. So on that time, these ports they can receive the BPDUs on that.
Is there any time limit for that?
That we have to discuss.
What if in root bridge some collision is there?
You are on switches and it's all about full duplex. There is no possibility for the collision. These are the advanced devices now. Okay.
Somehow it's shut down.
Somehow if it's shut down, so obviously network goes down. There's no other. In case in your network, if root bridge is down, there's no another option. Your whole network will be down there.
It's like
Not automatically.
Then another solution, configure HA. High availability means redundancy. This is down, it will become up. Okay, so backup you can say in normal language we can say as a backup. Then configure the backup. Let's consider I am not well, or if I have to travel. Let's consider tomorrow I have to travel. So now if I have to travel from Bangalore to Delhi, so obviously we need another trainer as a backup. Okay, So in the networks, always backup will be there. So then configure the backup and all. Clear? That concept is known as, normally we are saying HA, high availability there, otherwise we can say redundancy also. Backup concept. Then configure the backup there. Clear? Now, let's come back with packet tracer. I'm using 3 switches here. The same topology. Okay? And let me connect it here. Let it be started. It will take how much time?
30 seconds.
30 seconds. Now, disable state, I told you what is the disable? That is intentionally we have to use the shutdown command. Right now we are in listening state and we are in learning state. Listening state will take 15 seconds. Learning state will take again 15 seconds. Listening state means your STP process is going on. And learning state means it will try to learn the MAC addresses of their switches. It will try to learn what? MAC addresses. Note down please. And after listening and learning state, it will be in which state? It will be in the forwarding state. There is no timer in the forwarding state. Okay. Now, I have, okay, first note down. I have mentioned here A, B and C. So now tell me guys, which is my root bridge here? Just note down side by side and just
B.
B is my root bridge. How you can say B is the root bridge?
Two interfaces and forward states.
Because in this topology, in front of that there is a no block and no block here. Okay. This is fine. Same topology, sir. Okay. So we are in listening and learning state. I'll show you again. Let me connect once again.
In listening state, this traffic and as well as back address also flows, right?
Yes. LSN. LSN means learning state. LSN is what? Learning state. LSN, LRN means which state? All about learning state. Port priority, I told you what? 100? That is 128 actually. That is 128. Note it down. That is not 100, that is 128. Sorry for that. That was
What
wrong.
switch will do in the learning state? What switch will do in the learning state? I mean, what switch will
MAC address learning. They will try because we have one MAC address table. So they will form one framework for that. Okay, this is MAC address table.
Okay, then what is the necessary of flooding? Even if it's already know the MAC addresses of
No,
everything
it's
in the
just
last
trying to find out in case if some devices are connected on that. Okay, so it just try to form one framework for that. Okay, this is my MAC address table. It's not gonna update any type of MAC address table. Right now, see, we are FWD forwarding state. Show MAC address table. Nothing is there. Okay, so they are just trying to form the MAC address table. That's
It
it.
will be empty itself.
Obviously, because nothing, no devices is connected. But that state is known as still learning state. It will try to learn the MAC address. And whatever the root bridge, root port, DP port, alternate port we have decided, that is in the first 15 seconds, and that is all about listening state there. That is all about listening state. And each state will take how much time? 15 seconds here. So now see where we are. F00, and this is all about designated, and this is what? Forwarding here. So designated means I'm where? I'm on the root bridge here. This bridge is the root bridge. Shalini, one link, and can you see spanning tree is there? Because spanning tree is by default. We can disable the spanning tree. We can disable the spanning tree. First, I'll come on this one later. First, I'm coming back this one. So this is my root bridge. Let's open it. Now, how to check the spanning tree? Command is show spanning tree. Now, see here. What is the VLAN? By default, VLAN 1 is there. So that is that VLAN ID here. Okay. Spanning tree enable protocol IEEE. This is open standard, guys. So this is all about IEEE. Now we have two type of IDs. One is a root ID and second is bridge ID. What is the bridge ID? Bridge ID is all about switch priority and MAC address. So what is root ID now? Root ID is also same concept. Root ID is also the same concept, but there's a difference. Right now, see, if I'm talking about on this switch here, A plus 32768, consider it. B 32768. C, this is 32768. This is what? Bridge ID. Now, we have one more concept, root ID. Root ID means that is the bridge ID of the root switch. That is the bridge ID of the root switch. So what is the root ID? Who is the bridge here? This is the bridge. So what is the root ID? A plus 32768. Same here. What is the root ID? Root ID A plus 32768. Because who's the root? This is the root. And same here. What is the root ID? A and 32768. So if I'm talking about this switch, bridge ID means that is my local ID, my own identity. Okay. And what is the root ID? This is the root bridge identity. Here it's same because this switch itself is a what? Root bridge here. So this is my own ID and this is the root bridge. I'm the root bridge, so that's why this and this is same here. So but here it's not same because B is my local ID and this is what? My root bridge ID. Clear? Note down root ID and bridge ID. Interview question: what is the difference between root ID and bridge ID? Okay, so most of time on that time they will try to confuse you on this point here, because see, this is same, this is same. So what is the difference between root ID and bridge ID? So on that time don't be confused, it's not same. It's same on this switch because this switch itself is a what? Root bridge here. This is the reason why it's same here. Go with this one here. This is what? It's different or not? Clear? So note down root ID and bridge ID. What is the size of root ID and bridge ID? 8 bytes. Because MAC address is all about 6 and priority is all about 2. So 6 plus 2 equals to 8 bytes. 8 bytes means how many bits? 64 bits.
Can you open packet tracer once?
Packet is wrong.
So, you have to open that
CLI.
Say like, okay, say first note down this one. I'll open it. Okay. Note down this one. I'll open
Because there the priority is 327699, so that.
it. No problem. One by one. Yeah, I know. Because everything I can't explain at same time, T0. So T0, T1, T2, T3, T4 will take time.
Root ID for every switch and non-switch will be the bridge ID itself.
Root ID means bridge ID of root bridge.
So it will be same only.
Obviously. Because see, I am the root bridge. So what is my local ID? A plus 32768. Who's the root bridge? I am the root bridge. So what is my root ID? Same root ID. But for this guy, what is local ID? That is different. And what is the root ID? My ID, he will use as a root ID. Okay. Clear? Now, what is the switch priority, guys? 3, 2, 7, 6, 8. This is by default. Plus VLAN ID. That will be actual bridge switch priority. So 32768, and which VLAN is there by default? VLAN 1. So 32768 plus 32769. Okay, it's VLAN ID, not number of VLAN. VLAN ID is what? Let's consider 3276889. And now let's consider I'm using here VLAN 10. Okay, so now 32768 plus 10. What will be there? 32778. Okay, first do one thing, note down this one only. Note this one. Because if you have 10 VLANs, so then 10 spanning tree will be there. How many spanning tree process? 10. Because number of spanning tree equals to number of VLANs.
But we'll be defining only one VLAN.
No. This is by default 1. That's why only 1 is there.
No, when
But
we-
further once we will create 10 VLANs. So automatically 10 spanning trees will be there.
no, when we give the command as VLAN 10, so only one VLAN.
One VLAN will be there. But that will be second VLAN.
Not the second.
Yeah. Let's consider, right now how many STP? 1, because 1 VLAN is there. Next time 10, 20, 30. How many new VLANs you have created? 3. So how many new STP will be there? 3 more process. So 3 plus 4. How many STPs now? 4 STP. 3 plus 1, 4. Okay, because STP is all about PVST, per VLAN spanning tree. Per VLAN spanning tree there. In spanning tree there is a modes concepts we have. What are the modes? First is about CST, common spanning tree. Then we have PVST. Then we have PVST plus, and then we have PVST. These are the modes, and then we have protocols. What are the STP is what? One protocol. STP is in a what? Protocol. Then RSTP, one more protocol, and then we have MST, multiple spanning tree protocol. Clear? So STP is just P6. It's in just trailer. Even not trailer, it's just first some pictures. Okay, that's it. Okay, so redundancy, this thing, whatever the modifications over there. Okay, why my traffic is going from here, why it's not going from like this way. So welcome to spanning tree. Clear? Okay, now let's come back with this one here. This is my same road bridge case. Now 32769 is clear or not? Okay, bridge is the what? This bridge is the root. And yes, if you have multiple spanning trees, that is possible. The first switch will act as a root bridge for the first spanning process, and for the second spanning process that will be act as a NRB also. Means same switch, RB as well and NRB as well. Okay, let's come back with a single one. Come back here. Hello timer is what? 2 seconds. Means after every 2 seconds. In the VTP that was 300 seconds. So here what is the time word? 2 seconds here. Means after every 2 seconds they will exchange what? Bpdu, Bridge Protocol Data Unit. Hi, how are you? Hi, how are you? Hi, how are you? Maximum age 20 seconds over there. Note down these 3 timers. Hello timer, maximum age, and forward delay timer. Clear? Clear, guys? Now, hello timer 2 seconds, maximum is about 20 seconds, forward delay is all about 15 seconds. Let's consider I have two switches and that is connected like this way. This is connected. I need all the interfaces in which state? Forwarding state, because in the forwarding state I can exchange the data there. It's connected and wait for the how much time? 30 seconds. It's delay. This concept is known as forward delay. What is that? Forward delay. But total forward delay is what? 30 seconds. But in this CLI, what is the forward delay mentioned?
15
Only 15 seconds. This is always 15 seconds. Because forward delay is all about single state. That is all about listening. So automatically if we are saying it's 15, that will become 30 only. Because 15 into 2, because listening and learning state. Don't use 30 seconds here. Let's consider, don't try to be over smart in interview. Don't use it's 30 seconds. Because if you will say 30, so 30 multiplied by 2, that will become 60, and that is wrong. So what is the forward delay timer? 15 seconds each. You can see.
Listening.
Each means listening and learning state. Okay? Note it down. Forward delay timer is done. Maximum age timer. Let's consider hello timer done after 2 seconds. Okay? This is what? Alternate port. What is the state? Block state here. After every 2 seconds from here we are sending what? Bpdus, and this interface can listen the Bpdu here. Now this interface is down because of some issues and happen. Okay, and this interface is in the down state, not able to send any Bpdu. I'm waiting for the Bpdu here. Okay, 2 seconds done, next 2 is done, next 2 is done, next 2 is done, next 2 is done, next 2 done, next 2 done, but some timer will be there. So I'll wait up to 20 seconds. If within 20 seconds if I'll receive any Bpdu, so that's fine. Otherwise I'll become what? I'll become alternate. This is the reason why this is known as alternate. This is all about redundancy over here. If we are not getting any message here, any Bpdu from here, so then it will become what? Your DP port. Redundancy, and this is also known as, this is the reason why this port is also known as alternate port. Okay, so that is what? Maximum age timer. What is that? 20 seconds. Clear? So we have 3 timers here. Hello, then maximum, and then forward delay. This is all about 2, this is all about 20, all about 50. Note down please. Clear?
Once it turns into designated port, then the loop won't occur again.
Another interface is already in down state itself.
So that will become the block port.
If that will be comes up. Now, okay, note down. This is done. I'm on root bridge. This bridge is what? Root bridge. How many interfaces? 2 interfaces. What are the roles? Designated. Designated because on the root bridge all the interfaces are always in which state?
Designated.
Designated. What is the role? Designated. What is the state? Forwarding.
Forward state.
What is the cost? 19. What is the priority? 128. 128. Dot 1 and dot 2 means number of interfaces. Okay. Type is point to point, directly connected. Okay. Now, okay. Now, let me open this one here. Okay. this is, here we have one interface as a what? Alternate, say alternate we are using, means as a block, open this one. Show spanning tree. One is what? Root, what is the state? Forwarding. Another interface is what? Alternate,
Block.
what is the state? Block state. Go with the next one. Here one is what? Root and one is what? DP, and both will be in the which state? Forwarding state. Show spanning tree. Designated and root, and both are in which state? Forwarding state. STP, why do we need the STP? To avoid ALTO loop or no? Only? ALTO means between switches. This is my PC. Is this any ALTO device? No. But when I'll connect with switch, I'm just connected with the switch, how much time will it take? See, on the PC, port is ready, but here, how much time will it take? 30 seconds there. Okay? But why this 30 seconds here? Because these are the not two ALTO devices, because there is no possibility that there is a loop between end device and between ALTO device there. So really, do we need any STP on this concept here? Between end device and ALTO device? No, not at all. Here STP is not required. In this one. This is required because both are the what? ALTO devices. But here this is what? AND devices here. Let's consider on this switch I have 24 ports. Out of 24 ports, 2 ports I am using for this concept here. So on these 2 ports I need what? STP. But what about remaining 22 ports? Because on the remaining 22 ports I am going to be connect what? My AND devices. Let's consider I have AND devices. AND devices are there, and now let me connect it. All the devices are what? Will take how much time? 30 seconds. Why you are wasting my 30 seconds here? Listening and learning state. Really, do you need that 2 states here? No, because that state is all about spanning tree here. So the question is, can I skip these 2 states? Can I skip these 2 states? Can I come directly into your forwarding state? Because overall I need what? Forwarding state here. STP you can't remove, because that is by default properties. You can't delete it. Okay, you can't remove it. But I can skip listening and learning state. Means I can skip that 30 seconds. So let's consider on this interface, on this switch here, 2 interfaces are also connected, already connected. I'm going to play with the third interface. Go with the third interface. F01, F02 is already the part of what? STP, because I need STP process there. Go with the next interface F0/3. Spanning tree, port fast. Enable this feature. We have one feature. That feature name is port fast. The feature name is port fast. And what's the command? Go to interface, spanning tree, port fast. It's in a features. You are not disabling here STP. This is just a feature. And according to this feature, you will skip your listening and learning, because between end device and between switch, STP, that listening and learning state is not required at all. Okay?
By default it will be there. If we need I can.
This is done on the third interface. Let me connect one end devices here. Okay. Now let me connect it. This one. Just see here, guys. Everyone. Directly with state. Forwarding state. Is there any listening or learning state? Show spanning tree. F0 third, designated port, and what state is there? Forward. Directly. No listening, no learning. And on third interface itself, and go with the fourth one. This is now one more. Go with fourth. Have you enabled any port fast on the fourth interface?
No.
No. Will take what? 30 seconds. Go with this one. Show spanning tree. Can you see? LSN is going on. After LSN, LRN now, listen, learning, and then forwarding state. Okay, so port faster than the features which we use to skip your listening and learning state on the end devices. And what is industry practice? Out of 24 ports, if 2 ports you are using between the switches, then keep them as a default one. And on the remaining 22 interfaces, enable port fast. Because we have to enable what? We have to enable, we have to connect end devices over there. So then enable or configure port fast on the remaining interfaces. Clear or not?
And what if we connect the switch to that port? It will automatically disable or?
No, we have to disable first. As a network admin, this is your responsibility. Okay, first disable that features.
Then only we will. And port fast will work only for the end devices.
Only for the end devices. Because I don't need that 30 seconds. Listening and learning is not. Okay. Now, just consider, guys, its MAC address is A, MAC address B, MAC address C. This is a root bridge. Root bridge is connected with my edge device, which is all about router, and then I'm connected with the ISP. Whole traffic is traveling via A here. Okay. Yes, because that is the main switch. Okay, because I need internet access here. So how the traffic will travel? Via root bridge. Okay, so root bridge is always, this is all about core layer. Okay, so because we have some layers over there, access, distributed, and layer. So according to that, core layer is the main layer or the main concept, or you can say the devices which is connected with your internet and all. That is all about core layers. So this is the core switch.
What if you are connected to non-root switch?
No, you can't. It's in a practice. Okay. If you will try to connect, let's consider this is your root bridge. Okay. This is your NRB. And NRB connected you with the router and then ISP. I just want internet connection. Somehow, overall, in the STP, traffic will travel via where? RB only. So where now? Traffic is on the root bridge. Root bridge is not connected with this thing. How your traffic will be reached there? No. Okay. So no internet access. Clear? Let's consider this is your root bridge connected with the router and connected with the ISP. And I'm working in this company and today they just fired me. Okay. Only 1 hour is left. Okay. But still I have access of all these devices and network. What I'll do, I'll bring one more switch here. Okay. And I know in this one, in this concept, they are using their MAC addresses because MAC address is what? A, B, and C. Because I was the network admin here, so I'm aware about that. In this network, they are using their MAC addresses to decide who is the root bridge there. What I'll do, I'll connect my switch here. But let's consider its MAC address is G, which is high as compared to what? A. What I'll do, I'll change priority. Then I'll make it as a, let's consider 27000 something there. Less than that, immediately it will send one Bpdu here. Okay, hey, I'm the new root bridge because I'm having, but like it will send first Bpdu because first time it's there, it will try to first time it will send it and it will say, hey, I'm the root bridge. But on this one, who's the root bridge already? A is the root bridge. It's getting one more request here. This switch will check it. Okay, I'm getting one request, and that in that request, better bridge ID is there as compared to existing one. One more trainer is there. Let's consider if I'm going out and one more trainer will be there. He will say, I'm Hexa CCIE having 30 years of experience, 20 years of experience. I'll teach you CCNA. So you will be confused because new trainer is better as compared to existing one. So obviously, what are the things? Okay, let's go with the new one. So they will decide what? Who's the now new root bridge? This will be the root bridge. But this root bridge is not connected with the edge router. Whole network will be down. And now but don't do that. Okay. But this is one of the practice there. So as a network admin, it's a disadvantage or not? Let's consider I'm a junior network admin. For the senior network admin, it's in a what? Disadvantage there. Okay. Then what I'll do? I need spanning tree here. Okay. I'm out now. What about remaining 22 ports? So what I'll do? I'll configure one Bpdu guard there. Bpdu guard. It's in a features. Bpdu guard. What is guard? Let's consider in front of this building some one guard is there. Let's consider. What is that actually the task of that guard? If some unauthorized person is trying to come from outside to inside, that guy will stop him. Correct or not? Same Bpdu guard will do here. On the remaining 22 interfaces, you have to enable Bpdu guard. What Bpdu guard will do? If let's consider I have enabled Bpdu guard, and now with this interface you have connected with you have connected one switch, maybe intentionally or maybe not, doesn't matter. Switch is connected. Switch immediately will send what? Bpdu, and on this interface where you have enabled Bpdu guard, if this interface will receive any Bpdu, immediately this switch will be in which state? In the disabled state. And that is error disabled state, means that interface will be automatically down. Okay, and if this interface will be down, so after that if you are sending any Bpdu here, that doesn't matter because interface is already in the down state. So this time interface will be down, but not intentionally because of some error. Okay, so this state is known as what? Error disabled state. That state is known as error disabled state. Let's consider 1, 2, 3, 4 switches are already there, 4 interfaces. Let's go with the 5th interface. On the 5th interface, enable Bpdu guard. Okay, interface F05. Okay, spanning tree. Enable first port first. Okay, spanning tree. Bpdu guard here. Enable. Incomplete command. Enable. Bpdu guard is enabled on the which interface? 5th interface here. End device is obviously that end device. If you will connect end device, we won't get any result because end device is not going to be generate any type of Bpdu. I need what? Switch here. Let's go with one switch. Switch here. By default, this is the by default behavior or nature of the switch. If you will connect it, immediately it will send what? It will send the Bpdus here. Now, can you see now?
Disabled.
It was in forwarding state. Why? Because it was in port fast. But after that, when it started Bpdus, immediately now we are in which state? Down state. Open it. Show spanning tree. Is there any 5th interface? No, because that is down. Show interface F0/5. Fast Ethernet, this is what? Down. Line protocol is down. And what is the state? Error disabled. Now my network is secure. So on the remaining 22 interfaces, I'll enable what? Bpdu guard. If I'll fire someone, okay, and if that guy will try to connect switch, maybe intentionally or maybe by mistake, so there won't be any type of impact on my existing network because because Bpdu guard won't allow any type of Bpdu from outside to the inside, because actually this is what? This is my STP process is not. This is my STP. I don't want any type of Bpdu from outside. So on all the remaining interfaces, I'll configure what? Bpdu guard. BPD guard is clear. Port fast and BPD guard. Clear?
Port fast works only on the end devices.
Yes.
And then why
This is not work on end devices. It means you are you're just skipping listening and learning state. It's not, obviously, why we need port fast? Because I have to connect my end devices. I have to connect my end devices there. That's why I need that. But you can connect switch also. That it's not like that kids won't work with that. Okay. But what is the practice? Practice is on the remaining 22 interfaces, I have to connect what? And devices. Okay. If you will try to connect switch here, then again Bpdu will be there, and that will create the issue for my network. So I'll configure Bpdu filter in case by mistake if you have if you will connect switch there, so that will be automatically in the down state. Last thing, 1 minute. 2 features are done: Bpdu guard and port state. Oh, sorry, port
fast.
Port fast. Next is filter. Bpdu filter. See, this is one interface here. I have to connect what? End device here. Okay. First I have enabled what? Port fast. Agree with this feature? Why? Because we are going to be skip listening and learning state. Next is I'll enable Bpdu guard. It will protect my existing network from the outsiders. Means outsider BPDs there. If you are getting any BPDU with better bridge ID, better information as compared to existing one, that BPDU is known as superior BPDU. That BPDU is known as superior BPDU as well. If you want to write down, just note it down. Superior BPDU. If you are getting any BPDU and that BPDU is having better information or values as compared to existing one, so that BPDU is known as superior BPDU. Just 1 minute here, guys. See, done. Last 1 minute. See, guys, just use common sense here. You will get the answer. Port fast we have enabled to skip the 30 seconds. Bpdu guard I have enabled here because it will protect our network, existing network from the superior BPDUs. But this is switch and switch interface. But what is the basic behavior of the switch? Ki after every 2 seconds, it will send what? BPDU. After every 2 seconds, BPDU. Tell me, really do we need any type of BPDUs in this concept here? No. BPDU I need where? Here. Between switches, not between switch and devices there. So do I need this BPDU? It won't impact your network. But really do I need these BPDUs here after every 2 seconds? No. Why unnecessarily you are sending the BPDUs here? Okay. Then configure one more feature here. That is Bpdu filter. So that Bpdu filter will stop all the BPDUs from this end also. Clear? If in this class, if I'll start directly with the ISE, Identity Service Engine. So really is that required here? No, that is not required. So unnecessarily why you are sending the BPDU? Because that is not required, because I am what? I am the end device. For me, this is what? Totally useless. Okay. So on the remaining 22 interfaces, first enable port fast, will skip your listening learning state, then enable Bpdu guard, which will protect your existing network from the superior BPDUs, and third is enable Bpdu filter here. So then your switch won't send any type of BPDUs from those remaining 22 interfaces. Clear? So 3 features: port fast, Bpdu guard, and Bpdu filter. So you have to make sure that on the remaining interfaces you have to enable all these features there. And what is the command to configure filter? The command will be same, Bpdu filter. Spanning tree, let's go to any interface app 0/2. Spanning tree question mark. These are the options we have, and what about Bpdu guard, coast, guard here, link type, port fast, link. This particular switch means packet tracer doesn't support your filter here. Okay, you will get the command on the real devices. We don't have a concept here. We can change the coast, Bpdu guard here. What is a Bpdu guard? Don't accept Bpdu on this interface. From outside, if any Bpdu is coming and Bpdu guard is there, so don't accept it. It will goes into which state? Error disable state. Just Bpdu guard filter. Spanning tree, Bpdu at the place of the Bpdu guard, Bpdu filter. That's it. Show spanning tree. How many VLANs? VLAN 1 only. Right now it's not the part of the syllabus, but just for the practice. VLAN 10, exit. VLAN 20, exit here. Show VLAN. First, okay, not show VLAN. Show 3 VLANs we have now. Show spanning tree. Okay, it's showing here 1 only. Just let me 1 second. Interface app 0/1. Switch port, more access, switch port access, VLAN 10 here. Show VLAN. 1 interface I have assigned. Show spanning tree. So see, VLAN 1 ID. This is what? First spanning tree process. Second is what? VLAN 10. This is second spanning tree process. When how many states do we have? Only 1 interface. In first spanning tree, how many interfaces do we have? Second, third, fourth, and fifth. And the next VLAN, because VLAN 10, how many interfaces we have assigned? 1. That is what? Interface F01, and that is here only now. Clear? So it's all about PVST, per VLAN spanning tree. 100 VLANs, how many spanning tree? 100 spanning tree process. That's it. We are done with spanning tree. If you have any doubt, if you have any question, so you can ask. So I'm done with spanning tree. Thank you guys.